The moon is slowly shrinking, and that could be a problem. It's hard to spot from Earth, but the moon is shrinking in size and it continues to cool down. It's about 45 meters, that's more than 150 feet every few 100 million years. It's hardly a rapid change, though. A new study by researchers in the US suggests it might be enough to be responsible for landslides and quakes near the lunar South Pole. What makes this research particularly important is that the study area happens to be where NASA is thinking of landing astronauts in the future. If we're going to build a space station on the moon, it's best not to put it right in a geologically unstable zone. Our modeling suggests that shallow moonquakes capable of producing strong ground shaking in the South Pole region are possible from slip events on existing faults or the formation of new thrust faults, says planetary scientist Tom Waters from the Smithsonian Institute. The global distribution of young thrust faults, their potential to be active, and the potential to form new thrust faults from ongoing global contraction should be considered when planning the location and stability of permanent outposts on the moon. This study focused on what we know as lobate scarps, extended ridges that scientists think are caused by tectonic activity. Recent imagery from the Lunar Reconnaissance Orbiter was analyzed in tandem with recordings from the seismometers put in place during the Apollo missions, which operated until 1977. The analysis showed that one of the most powerful moonquakes ever recorded by the Apollo seismometers, a magnitude 5 quake, lasted several hours, could have been caused by one of the lobate scarps spotted near the moon's south pole, and on the moon it does not take much to trigger a serious landslide. You can think of the moon's surface as being dry, grounded gravel dust, says geologist Nicholas Schmer from the University of Maryland. Over billions of years, the surface has been hit by asteroids and comets, with the resulting angular fragments constantly getting ejected from the impacts. As a result, the reworked surface material can be micron-sized to boulder-sized, but all very loosely consolidated. Loose sediments make it very possible for shaking and landslides to occur. For now, scientists are still dealing with limited amount of data when it comes to the frequency and the location of moonquakes, but any insights, like the ones offered by the findings of this new study, are going to be useful in planning spots for future moon landings and lunar bases. As we get closer to the crewed Artemis mission's launch date, it's important to keep our astronauts, our equipment and infrastructure as safe as possible, says Schmer. And this work is helping us prepare for what awaits us on the moon, whether that's engineering structures that can better withstand lunar seismic activity or protecting people from really dangerous zones. The research was published on Planetary Science Journal, and this is on Science Alert by David Neild. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.